The frame of a passive house doesn't really get much attention. It's not as exciting as triple glazed windows or a cool mechanical system, but the truth is that it plays a really important supporting role, quite literally, in a successful passive house. To develop the framing strategy of a passive house, an architect has to consider the house's air barrier as well as its massive amounts of insulation. On this house, Steve decided to use a double stud wall strategy to meet the challenge. So Steve, what's the overarching philosophy to framing a passive house?
I try to be flexible and try to understand what the situation is for that passive house and treat the framing concept as more of an idea rather than a product. So for this house in particular, this was a pretty straightforward build, so the double wall structure lends itself very easily and economically. So when you're designing it, we might start with a 16-inch wall and realize we need to move to 17 inches. So all we're really doing is taking that inner wall and moving it in or out as we fine-tune the dials of the passive house calculation.
Did you consider any other framing strategies for the house? SIPs or ICFs? Or...
Not for this house. Because we had the square footage available, I feel the double wall system is the simplest, easiest to manage, construct, and utilize as far as developing the amount of insulation that we need in the wall system.
I noticed that the exterior wall is framed pretty conventionally, and what I mean by that is 16 on center, not advanced framing like I'm typically see in an energy efficient house.
One of the things that makes this house kind of framing specific is we're within a mile from the ocean here. We could have moved to 24 inches on center, but being in the high wind zone, trying to accommodate the building inspector, the walls are, 10-foot walls. So you kind of have to pick the battles you want to fight. There really isn't a penalty because we're thermally broken with the double wall assembly.
So what's the primary air barrier of our frame?
In this house, we used an exterior sheathing that has an integrated weather barrier.
So that's the zip system?
Yeah, we use the zip system here.
And how did you decide to use that product?
On the very last passive house I did, I kind of introduced myself to using that system, and it performed extremely well. We had some amazing results from an air tightness perspective, and it's a sheathing that the framers are familiar with.
Had you used zip system sheathing for this project?
We've used it on a couple of different projects. It's becoming more commonplace. It's just preferable to use because you don't have to wrap it with a house wrap. Once you put the sheathing on, it's got a coating on the outside that's weather resistant, moisture resistant, and once you tape the seams, it's completely, weatherproof.
What are the energy efficient details that you had to do that were different from a normal job?
Because this was an airtight frame, we had to use acoustical sealant on the bottom plates, the top plates, and wherever the seams were in the plywood.
Was the second floor the same deal?
Once we got to the second floor walls, we were able to platform frame, which means we were able to frame the walls laying down. So we were able to assemble the wall, square it, tack it down to the floor, and then sheath it while it was still laying down. The only difference between the first and second floor was on the bottom plate of the second floor walls, we had to attach a rubber gasket to air seal that bottom plate to the deck.
In addition to the sheathing tape on the outside, as a redundant barrier, we also have Tremco behind the sheathing. So kind of a belt and suspenders.
It's a belt and suspenders. But again, when you only have one shot to do this, belt and suspenders approach is a great way to be.
And what's the purpose of the plywood flange that goes above the wall cavity?
The plywood flange is because my air barrier strategy for the wall system is on the exterior. I switch it to an interior air barrier strategy in the ceiling and use the gypsum board and plaster as my air barrier. So I need to be able to make that transfer at the top plate.
So the primary air barrier runs from the outside sheathing across the double stud wall and onto the ceiling.
Yes, and it makes that continuous line around the section of the house.
What's the thinking behind the truss roof?
You're trying to minimize any loads that I bring down through the first floor, and the clear spanning roof trusses really help solve for that problem.
And really, in this house, you're only using the attic for insulation.
Yeah, in this house we have 30 inches of cellulose up there, and the beauty of the trusses is they come, you set them by crane, and you frame the whole roof in a day.
I think that was about a half a day that day.
It's a nice cost-effective way to go wall to wall.
The truss roof does go up a lot faster than a raftered roof system. It's nice because you don't have to build staging in order to access the upper part of the system. And we were able to swing these into place fairly quickly. I believe there were almost 50 trusses, and we were able to do it in about 3.5 hours.
And you were up at the top with a cherry picker, right?
I was up at the top of the cherry picker. I was directing the crane, and we had 2 guys on the exterior walls, one in the front, one in the back. So when the crane was able to swing the truss into place, I was able to grab the top and connect it to our bracing, and the 2 guys that were down on the exterior wall were able to nail them on layout to the top plate.
They chose the zip system once again to sheathe the roof, and with the building closed in, the framers stepped aside while the concrete slab was poured. Then they went back in to install sleepers and subfloor sheathing on top of the concrete before tackling the inside wall of the double stud assembly.
We were able to build the floor up 1.5 inches with PT sleepers and then install rigid foam insulation in between those sleepers. So not only is the slab insulated underneath, it's also insulated above, in between the concrete and the finished floor.
Talk to me about the inner half of a double stud wall. What are the tricks to putting that up and getting everything aligned?
Laying out the common studs was pretty basic. The exterior wall was already laid out, so you just had a matter of transferring common stud to the inside plate. The reason we left the window and door frame out was to make sure that it lined up perfectly. Because when the wall is laying down, once you stand it up and you have a wide open space where the window can be transferred, it's easier to take a framing square and make sure everything lines up perfect.
With the double stud walls in place, it was time for the drywall installers to complete the air barrier by hanging and plastering the ceilings. Although hanging the ceiling and then having to come back later to do the walls may at first seem like a hassle for the installers, it's more than offset by how quickly they can hang and finish the ceilings without any partition walls in their way. With this last part of the air barrier in place, the energy auditor was called in for the first of 4 blower door tests that are scheduled for different stages of the building process. This initial test lets Steve know how his primary air barriers are performing and allows the builders to correct any issues before moving on to the installation of the secondary air barrier. You made sure that the framers sheathed right over the windows and left it that way.
Yes, because if I do multiple blower door tests based on component installation, then I get to understand where my air leakage is being generated. Mm-hmm. Is it in the window installation? Is it in the sheathing? Is it in my insulation? So if I get those numbers along the way of construction, then I get to understand where do I need to focus on the next project.
So after we have the exterior sheathing up and we have the ceilings plastered, so we've got our primary air barrier, that's the first blower door test.
Yes.
And how did we do?
We did very good. Typically I strive for about 25% of our target number there, and I think we were right there with that number. We felt comfortable to move on to the next steps. The secondary air barrier is a 3 to 4 inch skim coat of closed cell foam on the inside. And that insulation does a couple things. One, it warms the interior surface of the exterior sheathing where you're at the risk of condensation in the late winter, spring months.
Okay.
As moisture moves through and migrates in the vapor format, it hits that cold surface, reaches dew point, turns to liquid, and you have condensation.
Which is very dangerous in a thick wall.
Which is very dangerous in a thick wall because I don't have energy to dry it out.
Right.
Like if you do a standard code built house with bad insulation, well, even if you get condensation in there, you have a high enough energy loss that it's going to bake the wall dry when the sun comes out on a nice warm spring day.
Right.
We don't have that luxury here, so we have to prevent it by making sure we're controlling the surface temperature of our condensing surfaces.
So that spray foam runs.
That spray foam runs all the way from the slab right up to that plywood bridge across the second floor top plate in pretty much a continuous fashion. And the beauty of the spray foam is you're able to get great R values quickly. You know, you're at 6.5 per inch. So you spray 3-4 inches of that stuff, you're at a typical code built house just with that spray foam insulation.
And that's before you even...
And that's before we even put the other 10 inches of cellulose in the wall.
With the closed cell foam installed, the second blower door test is conducted. With both the primary and secondary air barriers now in place, with no cutouts for windows or doors, this is usually the tightest point that the house will achieve. To finish insulating the frame, The insulators from Green Cocoon spent the better part of 2 weeks packing the walls and filling the attic with cellulose. Next time, we'll learn what it takes to source and install the type of high-performance windows and doors that are necessary to meet the strict requirements of a passive house.